Hello, my name is Dyllan Panetti, and today I'll be demonstrating proper analytical technique with a volumetric flask. This flask in particular is a 100.00 milliliter volumetric flask. And we're going to be transferring a pre-prepared saline solution into this container here, and we are going to quantitatively do that and then fill out the remaining volume to that 100 milliliter level for complete dilution. So I have here our pre-prepared saline solution, and we're going to begin by going and rinsing this volumetric flask. I'm going to kind of give it a nice coating of water on all the surfaces, ensuring that we get most of it. I'm going to give it a little whirl, rinse it out, make sure that there's no residual dust or anything else like that. And we're going to go ahead and take this water and, as it's wastewater, transfer it into the appropriate waste container. Now, typically, what you'll find is that there shouldn't be any residual water droplets above the indicating marker. However, that is very difficult to achieve when you're working with dirty glassware that hasn't been cleaned in an autoclave or with acetone, as is the case with these. So if you wanted to be completely accurate and not have to deal with any of these little droplets, you would actually properly clean the glassware instead of just leaving it for the next person. You can see there's a bit of fog right where those drops are. That's dirt, and that's why those drops are there. So we can try and get around that by rinsing it again, adding a little bit more water, and hoping for the best whenever we pour out. But it's kind of a crapshoot because of the fact that the glassware is by no means clean. So I think that's probably about as good as it's going to get. Now, what we're going to do to begin our analytical transfer, we're going to take this quart neck funnel. We're going to give it a quick little rinse on the inside here into our wastewater container. Allow that to go through. I'm going to place it into our volumetric flask. Now, in order to ensure the liquid doesn't form a seal and get sucked up between the two, we're going to lift it slightly, and we're going to go ahead and pour our saline solution into the volumetric flask. Now, a very important thing to note is that we're going to need to rinse this container. With something like saline, salt water, it is difficult to tell the residual amount of solution that is here, but it is significant. If this was food coloring, you would be able to more clearly see that with the dye, but we're going to give this a couple rinses, making sure to hit all the surfaces, collect up all of the residual solution with that solute that we're desiring to transfer. We'll go ahead and give that one more good rinse, rule of 3. Rinse the bottom too, give a little pressure. Okay, and transfer. Now, we're also going to transfer the residual solute that is on this funnel here, because there will be residual solute anywhere where that initial solution came into contact with glassware. I'm going to give that a good little rinse, okay? And now that that is all rinsed, we can go ahead and temporarily remove our funnel. Now that this is clean as a flask, what we can do actually is add a little bit of our solvent. Again, here water for a sodium chloride solution. You would use whatever solvent pair is appropriate for what you're working with. Again, water is the appropriate solvent, sodium chloride. And we can go ahead, again, use this funnel to kind of get us close enough. We want to leave a little bit of space towards the top here, actually. And the reason for that, as you can see in this volumetric flask, there are all these little bubbles. And that's no good. That's displacing volume and messing with the accuracy of this flask. So what we're going to do very quickly is take a bit of paraffin paper, stretch it out a little, and cover the top of this volumetric flask. We're going to give it a nice little shake, ensuring that there are no bubbles on the walls of this container. Do that, give it a nice little vigorous little shake. And we should be using some effort here. And once you see that a significant portion of the bubbles are gone, also flick it a little, that helps to release some of the residual bubbles. There's some of that bubbling. Go ahead and remove that paraffin paper. And now I'm going to go ahead and, using a Pasteur pipette, draw up this solution. And we're going to want to get this in here as close as we can to the bottom. Now, because of the fact that the glassware is dirty, we do have a bit of a predicament in that after mixing, now we have even more of those bubbles. And one of the ways that I have found it's very handy to get around them is actually to kind of use the Pasteur pipette to slowly apply a bit of suction as you grate up and gather up all of these little droplets. Now again, here we're going to go in fairly far down, release the load, and as we come up, and just grab some of those floaters as we steam. We're getting down to the bottom. Go ahead and wipe off that Pasteur pipette as we come in here for pretty much the final transfer. As we send down, go ahead and try and rub the nose of this Pasteur pipette and some of those little droplets. I'm going to pick up as many as I can. And go ahead and make your final transfer of the solvent. Okay. There we have it. 100 milliliters even transferred into the volumetric flask. Now, what you're going to notice is that there are these bubbles towards the ring. Normally, you wouldn't have this problem, but again, this glassware is not clean. If this glassware were clean, there would not be bubbles reoccurring like this. But the glassware was not cleaned, it was simply handed off to the next person. So that should be kept in mind whenever analyzing somebody's technique. So again, we will cover paraffin. And once more, bubbles would not be there if the glassware was clean. But there we have it. Proper analytical technique for the transfer of solution to a volumetric flask.